So now that we have seen control structures and functions as blocks of code, there is a little bit to be said about how we use variables within those blocks of code, right. So let's take a moment to examine what we mean by variables. What is the whole point of introducing the concept of variables in C? They are meant to be storage, right. I want to, let's say, have an integer or a floating point number or a string or a character or something of that sort somewhere, and I give it a name and say that this memory location or this part essentially corresponds to this variable, and I can then use that as an alias and write my code in a more easy to understand way. But the moment you have variables and you have different blocks of code, some questions start to come up, right? Who is allowed to access that variable? Let's say that there are two blocks of code that you have written. Are both of them allowed to access the same variable? Which one is allowed to read the code, read the variable? Which one is allowed to modify the variable? Are they both allowed to do it? And so on. This gets more tricky when you have multiple programmers working on a single program, right? How do you even do something like that? Well, you break up a program into functions, right? Each person works on a different function. It should work perfectly fine, but now the question becomes, can both programmers use the same names of variables, or is there some convention that needs to be followed about can they use the same functions, can they use the same variables inside functions? Am I allowed to use something like I, which is an index variable for a for loop, right? Or has somebody else already made use of it and I can't use that anymore, right? That would be quite horrible if I needed to invent new names for variables every time I wanted to run a loop. So the question that we are trying to answer is, how do we control the visibility, and the term that is used over here is the scope of the data, okay. So what do we mean by scope? You are probably familiar with this concept of something being out of scope, right, and there are many things in fact that are out of scope of this course. This is not one of them, right. So out of scope, as you can imagine, basically means it is not something that we can address in this particular course. In the same way, in the context of a block of code, saying that something is out of scope means that that particular block of code cannot even see that particular variable, cannot read it, cannot modify it, right. And scope in C generally works at that level, right. It's sort of works at the level of whether something can be seen. You do not easily have a way of saying that something can be seen but not modified, right. That needs some other kinds of restrictions on how you go about enforcing restrictions on code and so on, right, on the scope. So scope in C basically addresses multiple different kinds of topics, right. One is where is a variable declared, and can we use a variable without declaring it, right. Those who are coming from a Python background might know that you can actually use a variable without having to declare it first. In C you cannot, right. You have to declare a variable, only after that it even becomes visible to the compiler. The same way, if you declare a variable once, does it mean it can then be used anywhere? What does anywhere mean? Does it mean anywhere else inside that particular file that you have? Does it mean anywhere in any code that I have ever written in my life? Does it mean in any code that is present on the computer that I am using currently, right? Can I hide or override names? In other words, can I reuse a name that somebody else might have used, but I am not interested in that particular name? Can I reuse that for some other temporary purpose now without making my entire system crash because I assigned some value to pi that was not supposed to be, and that changes its value from what is expected in other places, right? It also introduces one very important notion called lifetime, right, which is basically how long does a variable exist in the context of a program, from the first declaration of the variable to the last use, that is the last time that it is used. C uses a relatively simple kind of block level scoping, right. We will see examples of that, right. But once again, just like with other things in C, the idea that you effectively restrict everything to the concept of what happens within these blocks of code means that understanding scope is in a lot of in most senses it's relatively easy and straightforward, right? It also imposes its own restrictions on what you can and cannot do, but for most practical purposes it turns out to be beneficial. Okay. So, let us look at some examples of scoping rules in C and how they apply. So, this example over here is a very simple demonstration of how we can use these curly brackets to define blocks and how that directly impacts the scope within which a particular variable is seen, right. So, what I have is my overall function starts at line 7 and goes on up to line 18, right. It is a block of code, as you can see from the curly brackets that are used to enclose it. Within that I have declared two variables, a which has the value 10 and b which has the value 15. Okay. Now, from line 11 to 15 you will see that I just have another block of code which is enclosed within curly brackets. There is no if before it, there is no while before it, there is no function name before it, it is just a block of code in curly brackets, right. And there is nothing wrong with this, nobody is complaining. As you can see, the compiler seems to be perfectly fine, and in fact that is true, right. It is just like you can also have something which looks like this, right. This is also perfectly valid code. The curly brackets and all these semicolons over here are doing nothing, they are empty statements, right. In the previous case, these curly brackets actually have a specific use, and what is that use? That is on line 12, right. I have once again declared int b. If I did not have these curly brackets, the first thing that you will notice, in fact let me just remove the two curly brackets, and you will notice immediately that there is one error out here which says redefinition of b. Okay. So, I cannot declare a variable twice. On the other hand, if I do go in there and put in the curly brackets, it assumes that this is another block of code, the error is gone. Interestingly, what that means is this b now has the value 20, which means that when I run these printfs I should see 10 and 20 out here. The question that immediately comes up is, what will happen when I print a and b out here? After all, I took b and I assigned it the value 20, shouldn't I expect to see the same value 20 when I go here, right? Let us try it. What we can see, oops, sorry, let me just uncomment out or comment this out. Yeah. What happens when we run this is it prints out first a is equal to 10 and b is equal to 20, right, which is what corresponds to lines 13 and 14. But then I print a is equal to 10 and b is equal to 15 corresponding to lines 16 and 17, right. So, a is unchanged, it still has its value 10. But when I reach line 17, the fact that I assign the value 20 to b is gone, is forgotten, right, because that ended with this block, right. This b effectively is a completely different variable from this b. They just have the same name, but they refer to different memory locations, and when I use it inside this block, it has a different meaning, right, which can be very confusing because remember that a is still visible inside this block. So, until the point where I had actually declared b is equal to 20, right, I have a value for b, and in fact you can verify that by trying to print it out here. If I run this, what I find is before b is equal to 15, right. So, at this point in time b has the value 15. At this point in time I have declared a new b. So, over here it becomes 20. When I come back out of this block after line 16, b goes back to having the value 15, right. Potentially this is confusing, and once again preferably avoid it unless you know exactly why you need to redeclare another variable with exactly the same name, right. Now this second demonstration that I wanted to show was actually just a concept of something called define before use, right, where I have these two printf statements, one of which prints out the value of a and the other prints out the value of b, but b is declared only after the printf statement. Now it does not even allow me to proceed beyond that, right. The only thing I can do is basically give up at this point, because it says that I have not even declared b. If I move this up, right, that error goes away and I can indeed run the code, which runs exactly as expected, right, no surprises here. It just prints out the two values that I have, but then everything is pretty much in order in scope, so there is nothing more to be concerned about. Now with regard to scope, as I said, if you declare a variable inside a function, that variable is visible everywhere inside the function. If I declare it inside a block inside a function, it is visible inside that block and not outside the block, right. And as an example of that, we can actually see what happens if we go into the original function that we had. In the original function that we had, supposing I declare something else out here where I say int c is equal to 30 and I printf the value of c, right. This should work fine, and indeed I see that c is equal to 30 comes out here. But what happens if I try the same thing and say print c is equal to 30 later? You will see that this is actually a compilation error, right. It does not even allow me to proceed. If I do try to run, it is going to give me an error use of undeclared identifier and make me stop right there. I can't run the program, right. That is because at this point on line 21 there is no variable called c that was declared only inside this block, right, and stopped existing after line 18, which by the way also brings us to this notion that I had mentioned called lifetime, right. The variable c first came into existence on line 16 and stopped existing after line 18. So in terms of the lines that we have over here, effectively the lifetime, the life of c is between those lines. The reason we call it lifetime rather than the life lines or whatever, right, is because we are usually interested in from the point of view of the actual running of the algorithm or the running of the program. And when the program runs, the variable comes into existence when we hit that line of code the first time, not when the compiler sees it, not depending on which particular line of code it was on, but depending on when in the flow of the program we get to that particular line of code, right. And it goes out of scope when I exit that block within which it is defined. So c basically lives from here to here in some sense. This particular b lives from here to here. A lives all the way from the beginning to the end of the function, and so does this other variable called b, right. So you can define these lifetimes and the sort of extent of a particular variable in multiple ways like this, and you can basically analyze it in terms of where it is declared in the function and where it goes out of scope. Now that we have seen that what functions can do with regard to the declaration of variables, what happens if I declare a variable outside a function? For example, out here, right, this int fsvar on line 39 is not inside any function. It is not inside main, it is not inside any of the other functions, it is just there in the file. This is effectively called a file scope, okay. And the file scoped function or variable in this case is something that from the point that it is declared, that is this line 39, all other functions that follow it can see what value it has and can alter it, okay. So for example, if I run this where I basically call these two functions demoscope31 and demoscope32, right, 31 is going to print out the value of fsvar and then set its value to 100. 32 is going to print out the value and set its value to 200. The first time I call 31, I do not know what the value of fsvar is supposed to be, right, but let us see what happens anyway, right, when I run it. Oops, sorry. So, you will see that the first time I ran this 3.1, it printed out the value of fs var equal to 0 and it set its value to 100, right, which means that when I went into 3.2, it prints out the value of fs var is 100, but then sets it to 200. I go back and call D1 again, it shows that the current value is 200 but then sets it back to 100, and finally when I call D2, it says that the current value is 100 and it has set it back to 200, but I do not see what the value is. Okay. So, the interesting thing over here is both of these functions, demo 1 and demo 2, were able to see fs var. On the other hand, if I try going up here and trying to do something like print fs var out here, right, I see the same error again, right. Basically it says that use of undeclared identifier fs var. Why is that? Because after all it is there in the file. The point is it came after the definition of this function. So, when I reach this function and my compiler is going through this function, it does not know about the existence of fs var. It says that there is no such variable, and the fact that you have declared it later is not good enough, right. If you wanted to use it, you should have declared it before you started this function. Now, one other interesting observation over here is you will see that this value printed the first time is fs var equal to 0, right. Now, from the apples, bananas, mangoes example, you might have remembered that if I did not initialize a variable, it could basically take on any value, right. But over here it seems to be behaving properly and is always showing the value 0. It is not doing that behaving randomly business. This is actually not a coincidence. It turns out that when you have variables declared in certain parts of your code, the compiler actually takes care of ensuring that they are initialized to a value of 0, right. In general, it is not something to assume, but that is also related to the scoping rules and to where exactly a variable gets instantiated in the memory of the system. More on that when we talk about memory and pointers in general, but for now it is just not, you do not need to sort of rely on it, but it is something that turns out to happen in practice. Now, the final thing with regard to scoping rules is that for loops in particular is one place rather where the local scoping is made use of very cleverly, right. Inside the for loop, it is possible to declare a variable as part of the initialization step, right. So, I can actually have int I equals 0 out here. What it does is that this integer, this value that is being declared at this point, will actually be visible through the rest of the loop. In this case, the rest of the loop is just the next line alone, right. And what will happen in this case is that it will actually print out the value, it will take this value, it will create this I as a new variable which has nothing to do with this variable I, okay. And it will go through, and once it has finished with the for loop, you should find that when you come back to the original I, it returns the old value that you had, right. And as we can see, what we have is the first I, it prints out 0, 1, 2, 3, all those are inside the for loop. But then the moment I get back, the fact that I printed out a different value of I over here does not matter. I basically get back the old value 25 that I see, right. To contrast this, let us see what happens if I just do not have that int I equals, right. I do not redeclare it, which means that I am now making use of the same I that I have already defined, right. It had a value 25, I am now running through a for loop. What is the value that you expect to see when you go back to the, well, not the original, it is the same variable, right. So, let us see what happens when we run this. Now, I find that the value is 4. Why is it 4? Because when the for loop exited, the first time that happened was when I got the value 4, which violated this condition, and it made the for loop get out, right. So, the value that gets printed out here is 4 because I have actually modified the first variable I that I declared, right. And if I, on the other hand, by doing this, I have effectively made it safe in some sense, right, because I have declared a new variable. I am sure that it is not going to interfere with anything else that I had, because by the time I get out of the for loop, I now have something, I have restored back to the original value that I was working with. Now, in some sense this is good, and I would normally recommend that you use this approach, but you need to be careful, because if you do have an int I that has been defined in this way, if you try to use it inside this for loop, right, inside the body of the for loop, if you want to actually make use of it inside the body of the for loop, you will find that this new I is effectively shadowing the actual value of I. I cannot see the actual global or the outside value of I inside the for loop anymore. Usually that should not matter, because these are only the counter variables inside the loops, right. But if there is a scenario where you are doing some other local initialization, be aware of the fact that you will end up shadowing something which is there outside, and you might end up changing the value that you are actually seeing, right. One last thing which you could, this is code that is valid C, right, rather I need to have the declaration of I, yeah. This is valid C, of course, right, I can have I equals I, j equals 0 and so on. Let us see what happens when I run through this over here, right. So, what's peculiar about this is that I have created a new variable called I, and I have given it the value of the old I, or at least that is what I think I am doing, right. So, does that work? It does not seem to work. What ends up actually happening out here is that it takes this value I, it now treats it as a new variable, because the moment it has declared the variable I over here, this is now a new local variable, right, and what it has done with it is it has basically initialized it to some unknown value, which it then assigns into I out here, right, and well, it prints that value out when you go through with it, right. So, in other words, the original value of I equal to 25 that you had over here is not what shows up. To be frank, is this even a good idea? Obviously not, right. Do not write code of this sort. Why does it behave this way? It is not entirely clear. This is most likely even compiler dependent, right, in terms of what kind of code it is going to generate. But one thing that is for sure is that this is not in general code that you want to write, right. It is almost certainly, at the very least, it is confusing, and there can be scenarios where it is outright also going to lead you to wrong results, okay. On the other hand, it is syntactically correct. So, that is something that you need to be aware of. So, these are some of the rules of scoping that apply in the context of variables and functions that are declared in C, and hopefully you have a clear picture right now of what are the different ways by which we can make use of them. The fact why you might want to make use of scoping rules, right, to redeclare variables in order to reuse names, to restrict the visibility or lifetime of different variables in different ways, right. All of those become useful when you are trying to write relatively large programs with multiple functions in them.